Hello, everyone. In this section, we actually start our statistics and probability chapter. The first half has to deal with statistics, and then the second half has to deal with how the probabilities occur that give us the data that we're able to do statistics with. So the first section is a lot of vocab, actually. So statistics is the study of the collection, analysis, interpretation, presentation, and organization of data. It's essentially the study of how we work with data. What do we do to understand that data? How do we make it easier for people to present and use it in real life? So people use statistics to answer questions about a population by taking a sample, and it is used in nearly every single occupation. Statistics is one of the most widely applicable fields of mathematics because data is everywhere, especially in the age of computers, when we can gather so much data so quickly and hard drives are just shrinking in size. So data has become a much bigger field since the invention of the computer. The population is all of the members of the group that we're interested in studying. So population is everyone or everything that we are studying in a certain situation. The sample is a subset, it's a portion of the population that we are studying and we believe represents the entire population. So if we want to know something about an entire population, then we take a sample. In a statistical study, why do they use samples? Why not just sample the entire population every time? Well, the reason, as you might have thought for yourself, is because populations can be big. If I wanted to, for example, say I worked for a clothing company and I'm determining the sizes that I'm going to make my shirts, I might want to know what the average size is for a male in the United States. What's their average height? So if I wanted to really know that, I would have to measure the heights of every single male in the United States. That's impossible. So what they do is we study a portion of that, and that would be the sample. So the reason that we don't just always study the population is because populations can be big. That would take a lot of time, money, and resources to study the entire population. In the following studies, what they're going to do then is they're going to give you some scenarios and they're going to ask you what was the population they were interested in studying and what was the sample of that population they actually chose to study. So situation number one, a researcher was interested in the effectiveness of a given learning program in prepping high school juniors nationwide for the ACT. So one school in each state was selected to participate in a test study. The population is what we're interested in understanding. We are interested in understanding all high school juniors in the nation. So population is all juniors in the nation. We want to know how well they do on the ACT. The population is all juniors. Well, we obviously can't sample all the juniors in the nation. So what they did is they sampled what they say. They said one school at each state. So the sample would be the juniors from the schools that were selected for this study. That is the actual sample. The population is we would want to know how effective this program is for all juniors in the nation. We can't do that, so we take a sample, and the sample would be those that were actually chosen for the study. Scenario number two, a researcher is interested in the average number of hours of TV watched per week by children under the age of 5. So they sample 100 Montana children under the age of 5 by looking up their hospital birth records. So what's the population we want to know? The population we want to know is all children, so all children under 5, but only in Montana, because that's where the sample was conducted. The population is only those that could have been selected, not some, somebody in West Virginia could not have been selected because only kids from Montana were selected. So the population would be all children under 5 in Montana. Sample would be the 100 kids actually selected. Scenario number 3, a high school principal is deciding whether the school should change its mascot, so she decides to survey some of the students. The population would be all students at the high school. All of them could have been chosen, but not all of them were, because that might take too much time. All students at the high school, that's the population. The sample would be those students that were actually surveyed. Population is everyone that could have been selected. Sample is those that were actually selected. Population is the group we want to really know about, everyone that could have been selected, and sample are those that actually were selected. You can think about it like a soup. If you want to know how hot the soup was, the population would be every single spoonful of soup you could take. The sample would be the spoonful you actually do to test how hot the soup is. Consider the last example of the principal surveying students about the mascot change. Why not just sample the football team? Well, problem with sampling just a specific group is it might introduce what we call bias, an unequal representation of the population. The views and opinions of just the football team might not represent the entire school. It might be too focused, so it might not represent the entire population. An example of that, using that soup analogy, if you've ever cooked before, you might know that the hottest portion of a soup when you're heating it up is near the rim, because that's the part that gets hot. The coolest part is in the middle. So if I were going to sample from the soup, I would probably not want to just let it sit there and then sample from the middle, because that would not be representative of the soup as a whole. The outsides would be hot, the middle is cold. A better way would be to stir it and then randomly sample from inside of anywhere. So what we do is we're trying to avoid bias. Bias is an error that results in a misrepresentation of a population. It occurs when one conclusion is favored over another based on the way that we sampled. So we sampled in such a way that it was not representative of the population. We sampled too narrowly or inappropriately. There are 5 ways that we can conduct a sample, and some are better at avoiding bias than others. The first and best way is a simple random sample. That's when each member of a population has an equal chance of being selected. This is the one that avoids bias the best out of all of them. An example using that principal selecting students for the survey would be maybe the principal randomly selects 100 students using their ID numbers. There's no reason to believe that ID numbers would have a bias, so you should get a nice representation of all groups of people by using ID numbers if you randomly sampled 100 students using ID numbers. The second type of sample is a systematic sample, and that's when people are regularly selected at a specified interval from a random starting point. So let's say students are sorted by their ID numbers, a random starting number is selected, and then every 5th student is asked to participate. So maybe in the program in PowerSchool, we do a random number generator, and let's say the number that comes up is like 1008, and then what we're going to do is we're going to survey every 10th student after 1008, maybe rewrapping back around. Another example of a systematic sample would be, let's say as kids come into school, it would be difficult to ask every student as they come in because you can't get answers fast enough because people come in too quickly. So maybe the principal surveys every 20th student. So the first student that comes in gets sampled, and then every 20th student afterwards gets sampled. That gives the surveyor enough time and hopefully should still be a nice representation. So a systematic sample is when you have a starting point and then you do every kth student or thing after that. That's what a systematic sample is. The third type of one you can do is a self-selected sample. That's when members volunteer to be included in the sample. They're self-selecting to be involved in the study. An example would be maybe an email sent to all students to their school email, asking them to participate if they would like. They decide if they would like to do the survey, so they are self-selecting. The obvious downside of self-selecting is only those that are motivated tend to reply, and only those with really strong opinions tend to respond. So you don't usually get a representation of those that don't care that much one way or another, but those are people in the population just like anyone else, so they should be asked as well. So the downside of self-selected is it tends to get an over-representation of motivated and strong-minded and strong-opinioned people. The fourth type of sample is a convenient sample. That might be when people are readily available or easy to reach. So an example might be maybe the principal just asks everyone as they come off the bus. The downside is the reason that they're readily available is because they have one thing in common. In this case, they rode the bus. So if you felt like you got a good representation of all students from just riding the bus, then maybe you ask them. An example of this or a reason why this one might not be great, it tends to be that the younger students tend to ride the bus more because as students get older, they can get a driver's license. And so if you surveyed only those that were on the bus, you might tend to get an overrepresentation of freshmen and sophomores, but maybe not. It just maybe depends on the scenario. So that's just something to think about. And the last one you can do is called a stratified sample. What happens, so stratified has the root word strata in it. Strata means layers. So this is a layered sampling. The population is first divided into layers, non-overlapping groups. Non-overlapping means everyone's only in one group. And then members are randomly selected within the groups. So example of this one might be maybe the principal splits kids up by their class level, and then they're going to pick 50 from each grade. The benefit of this is, you know, if she's picking 50 from each grade, that would be 200 students. If you just randomly sampled without separating into grade levels, out of those 200 students, there could be a situation where you get 100 seniors. So it would be an overrepresentation of seniors. So stratified samples are good if you want to get an equal voice for all groups because you think that there are defined groups in your population. And in this case, there are freshmen, sophomores, juniors, and seniors. So that's when stratified sampling gets used. One thing that stratified, self-selected. Yeah, okay, yep, we're good. I'm going to give you a chance to identify what type of sampling we have going on here. So, giving you some scenarios, and I'm asking you what type of sample was done, and is that biased or unbiased? So, pause the video now, give yourself a minute to try it, unpause it maybe once you've had a chance to try. Okay, here we go. First one says every fifth person at the Country Music Showcase is asked to name their favorite radio station. This is every fifth person. That's the one where they do it at every specified interval. That was the systematic sample that we talked about. So that's systematic sampling, where they do every kth individual. Why might this be biased? This is definitely going to be biased because they're coming out of a country music showcase. You're probably going to get an over-representation of those saying that they prefer country radio stations. So that's why, because it over-represents country radio. That might not be a good representation of the entire maybe town that you're looking at. Question number 2, the CEO of a large company divides his employees by gender and then asks 20 randomly selected from each group to participate in a survey. The type of sampling here is where we first divide them into their groups, their layers. So this is a stratified. The reason they do that is because they want to hear an equal voice from males and females. And this would be unbiased. There's no reason to believe that the way that we split them up is going to be inherently unrepresentative of the population because the population has equal numbers of males and females for the most part. So why? Because no reason to believe the groups don't represent the population. And you can get pretty bias crazy, so don't get bias crazy. Everything's going to have a little bit of slight bias to it. It's not just black and white, it's more levels of gray. So when we're asking about bias here, we mean a clear misrepresentation of the population as a whole. So just keep that in mind. Once you've decided on how you're going to sample people, The researcher then needs to decide what type of study is going to be done to gather information, and there are three main types of studies. The first one is a survey. We're all familiar with those. That's when data is collected from responses given about characteristics, behaviors, or opinions. Another name for a survey might be a questionnaire. So example might be to determine whether the student body is happy with the spring dance theme. The dance committee asks a sample of students for their opinion. That's a survey. An observational study is when members of a sample are measured or observed without being affected by the study. They are not controlled in any way. You're going to hear the phrase they are in their natural habitat. That doesn't necessarily mean that they're animals. It just means that you are not affecting them in any way. You're just letting them go about their daily business and you are recording what is happening. So an example, a gaming company watches a group of teens play a selection of video games and notes the ones they play the most. They are not controlling the group at all. They're just watching them naturally choose which games they like and recording the results. An experiment is when you do control the groups because you're actually splitting them into different classes. So in an experiment, the sample, the people that we select, or the things that we select, the participants is the term, are divided into two groups. The experimental group, that's the group that actually undergoes a change, and then there's the control group. That group is supposed to be representative of the population without any change adhered to them. The effect that the experimental group sees or doesn't see is then compared to the control group. So an example, a teacher administers a paper and pencil test to one of two algebra classes. He administers a computer-based test that covers the same material to the other class. The teacher then compares the scores to see if maybe students do better or worse with the computer version of the test than if they had to actually write it out paper and pencil and show their work. So those are the three types of studies. Be aware there's something that you've probably heard before. It's actually going on in 2020. A census is when every member of the population is surveyed, is questioned. So there is no sample when a census is conducted because the whole population was actually asked. That's why census results are only done every 10 years because it takes so much time and money to do it. So a census is when everybody is included. The population and the sample are actually the exact same. Okay, so we're going to practice some. They're going to give us a scenario and they're going to ask which situation, which type of survey, observational study, or experiment was done. So situation number one, a company shows 5 different commercials to a group of students and then just records their reactions. That is an observational study. They let the people watch and then just record the results. So observational study. Second one, scientists study the behaviors of 2 groups of rats. One group of rats is given sugar, the other one is given nothing, so no sugar. And then they want to see what the sugar's effect is on their ability to complete a maze. Are they quicker or slower with the sugar? Well, this is the definition of an experiment. They are controlling what one group gets, so this is an experiment. The last one, the school board is interested in parents' thoughts on building new schools in the district, so a questionnaire is sent home in the newsletter. That is a survey. Lastly, when a survey or experiment is conducted, just as in sampling, we obviously want to avoid bias. Bias in surveying occurs when questions are confusing, they encourage members to answer a certain way, if they cause a strong reaction, or if they address more than one issue at a time. All of those are ways that bias can be introduced in asking questions. Bias in experiments occurs when members of the control and experimental group are not chosen randomly. That means that the groups are inherently different. Here's an example. Do you think that President Obama is doing a great job, a wonderful job, or an absolutely terrific job? Well, this is done by a liberal media poll group, so they're obviously doing what's called a leading question. They're encouraging members to answer a certain way. There's not even an option to say that you kind of disagree. So that would be a biased question for sure. There's other ways. You could just say, how do you think President Obama is doing? So then that would avoid lead-ins. So determine whether the survey question or experimental design is biased and unbiased and state why. So question 1, do you like animals and would you ever consider having a dog or cat as a pet? This is biased because it asks 2 questions at once. You can't do that. You only have to ask 1 question at a time because how could you even say yes or no because you're being asked 2 things at the same time. So biased, 2 questions. in one statement. Second one, what type of music do you listen to? That is unbiased. That's just a question. If they said, isn't country music the best? That would be causing that'd be a lead-in question and causing a reaction. You're kind of answering the question for them. Last one, to study the effects of a new training method, a dog trainer tries the old method on a control group of terriers and the new method on an experimental group of retrievers. This is biased for an experiment because the two groups are inherently different. You would need a mix. You would need one of the groups to have a mix of terriers and retrievers and the other group to also have a mix of terriers and retrievers, because right now you're really testing two things. You're testing the new training method and terriers and retrievers. Maybe the new training method had no effect, but terriers or retrievers just tend to learn quicker than the others. So the reason that this is biased is because of what we said down here. You can have bias in the experiment when members of the control and experimental groups are not chosen randomly. We force them to be different. So members of the experimental and control groups not assigned randomly. You would need a mix in between the two. So otherwise you wouldn't know, is it the breed or is it the new training method that is causing the dogs to learn better or worse? And the last thing I would encourage you to do is maybe write one biased and one unbiased survey question that could be asked to gauge interest in a new menu item at a restaurant. So an unbiased question would be something like, do you believe that about a new menu item? You could just ask them to rate it on a scale of 1 to 10. That would be an unbiased question. There's nothing wrong with that. But if you ask them to rate it on like excellent, good, or great, they don't even have the option of doing not great. So you can come up with your own. But that's it for the very first section. Thank you very much and have a good day.